Hello everyone, myself Vishal Kumar Yadav. Today we will talk about the modulation and we will see that what is modulation, why it is used in communication and what are the different types of modulation. So in a broad sense, communication is the exchange of information either wired and wirelessly between two points which are far away from each other and this information could be voice signal, even a television signal. So, this low frequency message signal is known as the baseband signal. And if we want to transmit this baseband signal for a far distance, then here are some challenges, and we can't transmit it directly. But with the help of high frequency periodic signal, it can be transmitted. So, this is high frequency periodic signal which carries this baseband signal is known as the carrier signal. So the question is that how to impose this message of the baseband signal on the carrier signal. Now we know that any signal has three basic properties. This is amplitude, frequency and phase. So the modulation is the process where one of three properties of the carrier signal like the amplitude, frequency and the phase is changed according to the baseband signal. In other words, the process of changing some characteristics like amplitude, frequency and a phase of the carrier wave in accordance with the intensity of signal is known as the modulation. Then our first question is that why modulation is required. So the first reason to use the modulation to reduce the antenna size. So when the signal is transmitted wirelessly, the size of antenna is very important parameter. So the size of antenna is proportional to the wavelength of the transmitted signal. So let's say the size of antenna L is equal to the lambda divided by 4. Now the relationship between the frequency and wavelength can be given by the following expression. We know that C is equal to lambda into F, where C is speed of light and F is frequency of the transmitted signal and lambda is wavelength of the transmitted signal. For example, if the transmitted signal has frequency of 10 kilohertz, then its wavelength will be equal to C divided by F. So lambda is equal to C divided by F. So it will come out lambda is equal to 30,000 meter. And if the size of antenna is quarter of the wavelength, then the wavelength of antenna will come around as 7500 meter, and we know that this size of actually impractical, right? But in the other hand, if signal is transmitted at let's say 10 megahertz, then the length of antenna will reduce by the factor of 1000. That means in this case the length of antenna will be equal to the 7.5 meter, and this size of antenna is manageable. So that is one of the reason of the modulation. And then the second reason, to reduce the interference. So let's say if five different voice signal, this is our five different voice signal which are around in the same frequency f. In starting, the all signals frequencies are only f, and they are transmitted without modulation through a single channel. Then there will be here interference between them, and at receiver side they will not be get they will not get the transmitted signal. So here we will not get any transmitted signal. But if each signal is modulated at the different carrier's frequency, um, here f1 is the frequency of message signal first, F3 is the frequency of message signal 3, and F5 is frequency of the message signal 5 respectively. And all the carrier frequencies are relatively far away from each other. Then there will not be any interference, and all the signals can be demodulated at the receiver, and the message signal of its transmitter can be retrieved. So in this situation, we received the signal by transmitter. So using the modulation, the interference can reduced, and same time the multiplexing of the different signal is also possible. So these are some of the important aspects why the modulation is used to the communication. And next we will see type of modulation. So now let us see the different types of modulation. Here we have the complete classification of modulation. So broadly, there are two types of modulation: the analog modulation and the digital modulation. So if the message signal is analog, okay, if the message signal is analog, then it's known as the analog modulation. And similarly, if the message signal is in the digital form or in terms of 0 and 1, it is known as the digital modulation. So based on the type of carrier signal, this analog modulation can be further classified into two categories, and that is continuous wave modulation and pulse modulation. So if the carrier signal is continuous like a sinusoidal signal, then it is known as the continuous wave modulation. In this continuous wave modulation, the signal is sinusoidal signal. So we know as this is continuous wave modulation, and if the carrier signal is a pulse signal, then it is known as the pulse modulation. In first of all, let us see the different types of continuous modulation. So mainly there are three types of modulation, that is amplitude modulation AM, frequency modulation FM, and a pulse modulation PM. In case of the amplitude modulation, the amplitude of the carrier wave is changed according to the message signal. Okay, so here figure first shows the audio electrical signal. Uh, in other word, it is like a message signal. Whereas figure second shows the carrier waves of constant amplitude, and the figure third shows the amplitude modulated wave. So in if this is the message signal and this is the high frequency carrier signal, then the amplitude modulated wave would look like this. So as we can see here, the shape of the carrier wave changes in the positive half cycle when the signal is increased. Okay, in the positive half cycle, the signal is increased, the amplitude of the carrier wave also increased. During negative half cycle, the negative half cycle of the signal, the amplitude of the carrier wave decrease. Similarly, in case of frequency modulation, the frequency of the carrier wave changes according to the message signal. So with the increase in the amplitude of message signal, the frequency of modulated signal will also increase. Similarly, with the reduction in the amplitude of frequency of the modulated signal will also reduce. So in this type of modulation, the frequency of the carrier signal is modulated in proportional to the message signal, while the amplitude of the phase are kept constant. And in phase modulation, the phase of carrier signal is varied according to the low frequency of message signal, is known as the phase modulation. And second type of analog modulation is pulse modulation. So mainly there are four different types of modulation technique. This is pulse amplitude modulation PAM, pulse width modulation PWM, pulse position modulation PPM, and pulse code modulation PCM. And the second type of modulation is digital modulation. There are three different types of modulation techniques. First, amplitude shifting king ASK. Second, frequency shift king FSK. And third is phase shift king PSK. And this is the complete classification of modulation. Now we will see the modulation factor M. So here here we saw the modulation factor by M. So the modulation factor is the ratio of amplitude change of carrier to amplitude of normal carrier, and here EM is amplitude change of carrier, and EC is amplitude of normal carrier. So we will get M is equal to EM divided by EC. Here we will discuss some cases. In case first, when amplitude change of carrier EM is equal to 0 and the amplitude of normal carrier EC is equal to A, so we will get the value of M is equal to 0 divided by A, and it is equal to 0. Because in first case we can say that in the absence of signal carrier, here we see that there is no any signal message, here only carrier signal. So we can say that in the absence of signal, carrier wave is not modulated. Okay, because here message signal is absent. So the amplitude of the carrier wave remains unchanged. And in other words, we can say that here uh, we will get 0% modulated signal. Okay. In second case, when the amplitude change of carrier EM is equal to 1 and amplitude of normal carrier EC is equal to A, so we will get the value of M is equal to 1A divided by A is equal to 1A is equal to only 1. So in the case second, when the signal amplitude and the carrier amplitude are same, here the amplitude of carrier wave is also A and the amplitude of signal wave is also A, and the both are equal to each other. So in this case the value of carrier amplitude varies between 2A to 0. Okay, the total amplitude here the total amplitude of modulated wave is 2A, and is vary between plus 2A to 0 and negative 2A to 0. In this case, we can say that here modulated signal is 100% modulated. And in third case, when the signal amplitude is one half of the carrier amplitude. Here we see that the amplitude of carrier signal is A, and amplitude of signal wave is 0.5 times of carrier amplitude. So when the signal amplitude is one half the carrier amplitude, it is varies between 1.5A to 0.55. This is our total amplitude of AM wave, and it is vary between 1.5 to 0.5A. So the carrier, we can say that here the carrier is 50% modulated, and in case 4, when the signal amplitude is 1.5 times the carrier amplitude, here the amplitude of carrier signal is A, and amplitude of signal message is 1.5 times of carrier amplitude. So we can say that the signal amplitude is 1.5 times the carrier amplitude. So the maximum value of carrier wave is becomes 2.5. It is the summation of the total total amplitude of the modulated wave is the summation of 1.5a, which is amplitude of signal, and and 1a, which is amplitude of carrier wave. So 1 plus 1.5 is equal to 2.5 a. So we can say that in this case carrier is 150% modulated. Now next we discuss about the percentage of modulation. Okay, when we show the value of m is in percentage, it is called percentage modulation. So we know that the value of m is equal to the em divided by ec. So here we see the total value of Emax is equal to the EC plus EM. Okay, here the total value of Emax is the summation of EC plus EM, and value of E min is difference between EC and EM. So here we will get Emax is equal to EM plus EC, and E minimum is equal to EC minus EM. So the value of summation of Emax and E minimum is equal to the 2EC, and we will get the value of EC is equal to Emax plus E minimum divided by 2, and difference between Emax and E minimum is equal to the 2EM, and we will get the value of EM is equal to Emax minus E minimum divided by 2. But we know that the value of m is equal to em divided by ec. So here we put the value here, and we will get the value of m is e max minus e minimum divided by 2 over e max plus e minimum divided by 2. Here 2 to cancel out, and we will get the value m is equal to e max minus e minimum over e max plus e minimum. So when we show the value of m is in percentage, it is called the percentage modulation. Okay, so we will get the percentage modulation m percentage is equal to e max minus e minimum over e max plus e minimum into 100%. And now we will talk about the amplitude modulation. So here we discuss the mathematical expression of amplitude modulation. So we know that in amplitude modulation, this is message signal and that is carrier signal. In positive half cycle, when the amplitude of message signal is increased, then carrier signal is also increased, and we will get maximum amplitude. This is our maximum amplitude. And in negative half cycle, of message signal, the carrier signal also negative, and in this situation uh, we will get minimum amplitude. So in amplitude modulation, uh, we we see that em is equal to em cos omega m t, and ec is equal to ec cos omega c plus theta. Here em is equal to instantaneous voltage of signal, and capital em is equal to amplitude of signal wave, and here omega m is equal to 2 pi fm. Omega m is equal to 2 pi fm. Here omega m is angular velocity at the signal frequency fm. Okay, and similarly ec is equal to instantaneous voltage of carrier, and capital ec is equal to amplitude of carrier wave. Here omega c is equal to 2 pi f c, and omega c is angular velocity at the signal frequency fc. So amplitude of AM wave is equal to EC plus EM cos omega m t. Okay, and we will write it EC plus m EC cos omega m t, because we know that m is equal to the em divided by EC. So when we get the value of em from this formula, we get the value of em is equal to m into EC, and we write the value of em m into EC. And in third step, we carry out the common EC, and we will write it EC in bracket 1 plus m cos omega m t. So the instantaneous voltage of AM wave E is equal to amplitude of AM wave, amplitude of AM wave into cos omega c t. And we will write it E is equal to, here we see that the amplitude of AM wave is equal to EC 1 plus m cos omega m t. So we can write here, we put the value of amplitude of AM wave in this place, and it is multiplied with cos omega c t. So the value of E is equal to the, here we see that we multiply EC with a with 1 and cos omega c t also. So we will write it EC cos EC into 1 into cos omega c t. So we get EC cos omega c t plus EC m cos omega m t into cos omega c t. EC into m cos omega m t and cos omega c t. Okay, and then we will get E is equal to EC cos omega c t plus, here we can do one thing, that we multiplying and divide by 2 from this, for this parameter. So we will get m EC divided by 2 in bracket 2 cos omega m t into cos omega c t. Okay, so we will get E is equal to em cos omega c t plus m EC divided by 2. And we know that from trigonometry we have the formula 2 cos a cos b is equal to cos a plus b plus cos a minus b. So let us see that omega c is a and omega m is b. So according this formula, we will write these 2 cos omega m t into cos omega c t. Here cos a is equal to the cos omega m t, and cos b is equal to the cos omega c t. So we will write this cos a cos b. Here vc is the value of a, and vm is the value of b, and we will write first first term is our first term is cos a plus b. So cos a, here this is the cos a, and this is our cos b, and plus cos a minus b, this is our a, and this is our b. So we will write 2 cos omega m t into cos omega c t is cos omega c plus omega m t plus cos omega c minus omega m t, and we will write it is equal to EC cos omega c t plus em EC divided by 2, and we multiply m EC divided by 2 individual with cos omega c plus omega m and cos omega c minus omega m. So we will get m EC divided by 2 cos omega c plus cos omega c plus omega m plus into t plus MEC divided by 2 cos omega c minus omega m. So here we have three different types of angular frequency: omega c plus omega m, and omega c minus omega m. So there are three types of frequency also, where fc is related to the omega c, and fc plus fm is related to the omega c plus omega m, and fc minus fm is related to the omega c minus omega m. And fc is our carrier frequency, and fc plus fm is our upper side band frequency, and in short we call it the usb also. And the difference between fc and fm is equal, it is called lower side band frequency, in short lsb. But we know that omega c is equal to 2 pi fc, where fc is equal to carrier frequency and omega m is equal to 2 pi fm. Here fm is our message frequency. So we will write the value of E is equal to the EC cos 2 pi fc into t plus m EC divided by 2 cos 2 pi in bracket fc plus fm into t. This is our USB frequency. And MEC divided by 2 cos 2 pi fc minus fm into t, and this is our LSB frequency. Now we will discuss about power in AM wave. So we know that the total power of AM wave is here PT is our total power, and PC is our carrier power, and PS is our total sideband power. So the total power of AM wave is equal to the PC plus PS, and we know that the formula of P is equal to V square divided by R. So uh, so the carrier power PC is equal to the EC divided by root of 2 and its whole square over R is equal to the whole square of EC divided by 2R. Here EC divided by under root 2 is we will consider its RMS value of EMF, and our total sideband powers PS is equal to the whole square of MEC divided by 2 under root 2 over R plus summation of whole square of MEC divided by 2 under root 2 R, because this is our USB and this is our LSB. So this is the value of USB and that is the value of LSB, both are same, and we will get the value of PS is equal to the M square EC square divided by 4R. But we know that the total power PT is equal to the carrier power and summation of carrier power and sideband power. So PT is equal to the EC square divided by 2R plus M square EC square divided by 4R. This is our PT. Okay, this is our PT and this is our PS. So PT is equal to EC square divided by 2R plus M square divided by M square EC square divided by 4R. So we will get the value of PT is equal to the EC square over 2R. Here um, uh, we will carry out this common, and we will get EC square divided by 2R in bracket 1 plus M square divided by 2. So the total transmitted power PT is equal to the EC square and over 2R in bracket 2 plus M square divided by 2. So PT is equal to the PC in bracket 2 plus M square divided by 2R, because this is our value of PC. Okay, so um, we will write it EC square divided by 2R is equal to the PC. Okay, so now let's see efficiency of AM wave. So the efficiency of AM wave is the ratio of sideband power PS to total power PT, and we will get in our in prior the value of PS and PT. So we put the value of PS and PT in this formula. We will get m square into EC square over 4R divided by EC square over 2R into 2 plus m square divided by 2, and we will write it m square EC square divided by 4R into 2R, because this side is, this is our a divided by b, and this is our original over, and c divided by d. So we can write it a divided by b into d divided by c. So we see that here r cancel out 4, and 2 cancel out, ec square cancel out. So here we will get the efficiency of AM wave is m square divided by 2 plus m square. Okay, now here we will see the limitations and advantages and the uses of AM wave. So the AM wave is used in radio broadcasting and in television transmission. It's used for picture signal, and this is our some limitations of AM wave. Our first limitations is low efficiency. If modulation is 100%, okay, if the modulation of AM wave is 100%, the sideband power is only 1/3 of the total power. Okay, sideband power is PS divided by PT is equal only 1/3 when we get 100% modulation by the AM modulator. Okay, so the value of PS is equal to the 1/3 of total power PT. Okay, PS is equal to the 1 by 3 into PT. So if modulation is 100%, the sideband power, PS is our sideband power, so the sideband power is only 1/3 of the total power of AM wave. So the efficiency of this type of modulation is very low. And our second limitations is small operating range. So AM wave is the operating range of AM wave is very small. So messages can't be transmitted over larger distance. And our third limitations is it is noisy reception. AM detectors are sensitive to the noise. So an amplitude modulated signal is prone to high levels of noises. Here some advantages also of AM wave. Um, First advantages is simple to implement, and second is AM wave. AM wave has have low bandwidth, and third is AM transmitter are less complex. So these are some advantages and the limitations of AM wave. Now we will see the sideband frequency. Okay, and this figure shown the sideband frequency in AM wave, and this is the spectrum of sideband frequency. Here figure shows the frequency spectrum of AM wave. The frequency component are shown by vertical lines. This is our vertical lines, and These lines are so the frequency component. Um, this is our carrier frequency fc, and this is our USB upper sideband frequency, and it is the summation of fc and fm, and this is our lower sideband frequency, and it is difference of fc and am. So it may be noted that carrier frequency fc, here this is our carrier frequency fc, is this carrier frequency fc is many times greater than signal frequency. fc is many times greater than signal frequency fm. Okay, so the sideband frequency are generally close to the carrier signal. Okay, we will see it in this example. Let us see, let us consider if carrier frequency fc, okay, if carrier frequency fc is equal to the 100 megahertz, and signal frequency fm is equal to the 1 megahertz. So the value of lsb is the difference between fc and fm. Okay, usb is difference between fc and am, so we will get the value of lsb is 100 minus 1 is equal to 99 megahertz, and upper sideband frequency is the summation of fc and fm, so we will get the value of usb is equal to the 100 plus 1 is equal to 101 megahertz. So we can say that the sideband frequency lsb and usb are generally close to the carrier frequency fc. Okay, and this is our bandwidth of the am wave. um, it is the difference between highest and lowest content frequency in the signal, and it is also difference the band of the signal. Okay, so the bandwidth bit is equal to the difference between upper sideband frequency and lower sideband frequency. So we know that the value of USB is equal to the FC plus FM, and value of LSB is equal to the FC minus FM, and we will put this value, and we will get here USB is equal to FC FM summation of FC FM, and LSB is difference between FC minus FM. So here FC are cancel out, and we will get 2 FM. This is our the value of our bandwidth frequency. Okay, so in amplitude modulation, this BT bandwidth is twice the signal frequency FM. And now we will discuss the generation of AM modulation. And we generate the AM modulation with the help of transistor AM modulator. Here a modulator is an electronic circuit, and a circuit which does amplitude modulation is called AM modulator. So this is our circuit diagram of transistor AM modulator. So this figure shows the circuit diagram of AM modulator, and it is common emitter amplifier circuit. So here this is a transistor, and this is our emitter resistance Re, and this is our emitter capacitor Ce. Now we have a collector resistance Rc. This is connected with voltage source Vcc. Now in the base side of the transistor we have the input capacitor Ce, and carrier signal Ec. Okay, now this is our coupling capacitor Cc, and it is connected with load resistance RL. Now we have to give the input signal in the emitter circuit. This is the audio signal Es, and here we will apply the carrier signal Ec in input side. So we have two resistance here, we have two resistance R1 and R2, and these are the voltage divider resistance of this circuit, and Cin is input coupling capacitor, and CC is output coupling capacitor, and the CE is bypass capacitor to bypass the signal current to the ground. Okay, so let us discuss about the working. Um, this circuit is common. This circuit is a common amplifier circuit having a voltage gain of A. Okay, voltage gain of A. The carrier signal EC. Okay, the carrier signal EC is applied at the input side of the amplifier, and the modulated signal ES is applied in the emitter resistance circuit. Okay, the amplifier circuit amplifies the carrier by the factor A. So the output is AEC. Okay, output is our AEC. Here the modulating signal is the part of biasing circuit. Okay, modulating signal is the part of biasing circuit, and it produces a low frequency variation in the emitter circuit. Okay, so the output is that amplitude of the carrier varies in accordance with the strength of the signal. So we get modulated outputs across the load resistance RL. Here only modulated signal should influence the voltage gain A. I repeat it. Here only modulating signal should influence the voltage gain A. So the gain of transistor amplifier is highly dependent upon the emitter current. Okay, the gain of transistor amplifier is dependent upon the emitter circuit. Okay, so the modulation is applied at the emitter, and the total emitter current follows the instantaneous modulating signal, and it is given by, okay, here we see the gain of amplifier A is equal to V out divided by V in. So the value of V out is equal to A into V in, and here V in is equal to the EC. Okay, so we will write it V out is equal to A into EC. Okay, so the instantaneous modulating signal, and it's given by IE is equal to IE plus K1 EM cos omega m t, and modulating signal is given by EM is equal to EM cos omega m t. Here K1 is constant, and I is constant value of the emitter current. So the alternating current IM is proportional to the directly proportional to the EM, and here we will write it Im is equal to K1 EM, where K1 is constant. Okay, and we will get the value of Im is equal to K1. Here this is the value of EM, so we will write it K1 into EM cos omega m t, and from the equation first we will write it okay, equation from equation first I is equal to IE plus Im from equation first, but we know that AV is directly proportional to IE. Here AV is the function of IE. Okay, we know that the voltage amplification of the amplifier AV is a function of the emitter current IE. So AV is directly proportional to the IE. we will write it AV is equal to K2 IE. Here K2 is a constant, and we will get the value of AV is equal to K2, and this is our I2. Okay, this is the value of sorry, this is the value of our IE. So we will get AV is equal to K2 into IE plus K1 EM cos omega m t, and the carrier signal EC is equal to the EC capital EC into cos omega c t, and the output voltage V0 is equal to AV into EC. Okay, because A is equal to the V output divided by V in, and value of V output is equal to the V A into V in, but we know that V in is equal to the AC, so we will write V output is equal to the A into EC. So the output voltage V0 is AV into EC. So V0 is equal to the, this is our AC AV, this is our AV, and this is our EC, this is the value of EC. So we will write it V0 is equal to K2 into IE plus K1 EM cos omega mt into EC cos omega c t, and we will get the value of V0 is equal to the, here K K2 is multiply with IE and EC cos omega c t. So we will write it K2 into IE into EC cos omega c t. Okay, and plus K2 into K1 EM cos omega m into EC cos omega c t. Okay, so we will get the value of V0 is equal to K2 IE EC cos omega c t plus K1 K2 EM EC. Here we multiplying and divided by 2. Okay, so we will get K1 K2 EM EC divided by 2 into 2 cos omega mt into cos omega c t. So from trigonometry, 2 cos A cos B is equal to the cos A plus B plus cos A minus B. Okay, we will write this equation, and we will get the value of V0 is equal to the K2 IE. Here we carry out IE, we carry out common from both parameter. So so we will get the value of V0 is equal to the K2 IE in bracket EC cos omega c plus K1 EM EC divided by 2 IE. Okay, and in bracket, because I will carry out the value of IE, so in denominator here IE is I am writing here IE. Okay, and and uh, and we will get cos omega c plus omega m t plus cos omega c minus omega m t. So we will write it V output is equal to the K. Okay, here K2 into IE. Okay, here K2 into IE is equal to K. So we will write it K into EC cos omega c t plus the value of m is equal to, we know the, we assume the value of m is equal to K1 EM IE. K1 EM IE. This is our value of m. So we will get m EC divided by 2, and in bracket cos omega c plus omega m into t plus cos omega c minus omega m into t, where k is equal to K2 and IE, K2 into IE, and m is equal to K1 into EM divided by IE, and this is the equation of amplitude modulated wave. So in this way, my topic is completed, and I hope today's topic is understood by all of you. Thank you.